One.
Okay. Hey, everybody. My name is Kunal Bandarkar, and over the summer, I interned at VMware, and I worked on a consistency checker tool, and I'd like to share that with you guys today. So a little bit of background on who I am. I'm a rising junior at UCSD, and I'm majoring in computer engineering, and I just actually transferred from University of Washington. So those of you who may remember me from last year, I did make the transfer this year. And I'm a second year returning to the controller infrastructure team at Avi Network / VMware.
No, I didn't know you were from UCSD. Go UCSD.
Yeah, go UCSD. Okay, so let's get into the project itself. So the problem that this project is addressing is when debugging issues with objects in basically SE Datastore Postgres and the SE agent GraphDB. We run into three main issues, and one is the SE Datastore consistent with Postgres, or is there some sort of diffing bug involved? Two is the SE Datastore's graph representation consistent with the DB cache? And three, does the SE Datastore and graph SE Datastore object graph match that in the SE agent GraphDB? And right now, there's no real quick way of making sure that all of these steps check out. It's a very time-consuming process, and that's what this script is aimed to solve. So solution is a consistency check that for root level objects that automates verifying that an entire object graph is consistent across the following data sources. And this is Postgres, SE Datastore, and the SE agent GraphDB. So again, the solution is a script, consistency check.py, that essentially takes in a set of root objects and diff objects if the user chooses to do that. And on a high level, it basically creates a PV map and parses the user's arguments to make sure that they're valid. Then constructs a object graph after querying Postgres, the SE Datastore, and the SE agent GraphDB. And then it outputs a side-by-side comparison of those graphs, or it outputs a diff on objects in those graphs, given the user's option. So really quickly, I'd like to give you guys a demo of this tool. So right here are some of the use cases. So you can run it as consistencycheck.py and then pass in your set of root objects. Or you can run it as consistencycheck.py, pass in your root objects, and then pass in a diff object, which is an object that you want to compare between Postgres, SE Datastore, and SEs. You can furthermore specify walkbacks, which is a way of comparing objects at different versions. If they've changed between versions, there's no real way to compare them unless you walk back. And this is only the case for the SE Datastore and the SEs. And we set walkbacks as a default of 5 because it's an expensive operation. And but if a user wants to walk back an object further than that or less than that, they can set that accordingly. Then you can set a pretty print option for the diff. So some diffs are super, super complicated and really hard to read. And that option will make it really easy to read for you. And the other option is to write to a file. So this is just if in case you want to store this diff somewhere and refer back to it later, you can do that. So why don't we call this script? So right here, you'll see Python consistency check.py, and we'll pass in a root object. But as you can see, I misspelled virtual service. So this is actually not a valid object. And the important thing to note here is that before constructing any object graphs, it'll actually go through an argument parser and say that this object has failed because it's not a valid object. So why don't we correct this object and try running it again? And this time we're actually going to pass in a network service object. So now it's passed the argument parser and it's going to start building the graphs. And now that it's built the graphs, this is what it looks like. So you have a side-by-side comparison of Postgres and the SE Datastore given the version 181. And you get a nice message saying that all objects match. And this is a network service object, and there aren't that many there aren't that many objects in the object graph, but for virtual services, these graphs can get quite large, and it's very useful to have a side-by-side comparison. So as you can see, SE datastore is missing a VRF context object, and then you can compare SE datastore to service engines, and the service engine is missing a service engine group object, but these are all expected to be missing. So yeah, you can see the different versions. You can see the SEs are lagging behind in versions, and then why don't we try passing in another root object? Because you can pass in multiple. So again, I pass the argument parser, and now it's going to start building the graphs. So as you can see here, we don't get any nice green messages anymore because in these virtual service object graphs, there are diffs present on certain objects. In this case, truth be told, I did construct I designed these diffs to occur. So this is how it would look. A red object basically indicates that there's a diff between versions. And if you were to see an object in bold, it means that this object has changed between the versions of the objects that you're trying to compare. So in this case, you have tenant admin that's been changed, and the virtual service runtime object that's also been changed. And then if you scroll up, you'll still see your network service object graphs. And one other important thing to note, actually, is that for the network service object, we're seeing multiple service engines because those service engines all have the network service object, and they're also expected to have that. But when you're asking for the virtual service object graph, you're only going to see one service engine because that's the only service engine that's expected to have that object graph. So all the irrelevant service engines are not printed to save space. And another thing to note is that if a SE is expected to have a VS root, that'll actually be outputted right below this graph saying, this SE is at version 181 and is expected to have this root, but it does not. So now that we've seen that there are diffs, why don't we pass in a diff object? And right here, we're just going to grab tenant admin. And once again, it passes the argument check, and it'll start building the graphs. But this time, instead of outputting a graph, it'll output just diffs. So right there. So as you can see on network service root objects, there are no diffs found on this object, but when it comes to the virtual service root, there is a diff where before it was changed from admin to hello world. And you can see the versions that those have been changed as well. So this was a pretty uncomplicated diff. It's just one little field change, but you'll see here in the virtual service runtime, there is a slightly more complicated diff, and I think it helps to have a pretty print option. And this is actually a little bug that I worked on with Rahul, and it was very useful to actually write this to a file to refer back to later. So let's write it to test file. And as it's running, you'll see that it fails the argument parser because test file already exists and it won't overwrite a file. So this is just another way it saves the time of building graphs by checking arguments beforehand. So now that I've removed test file, it passes the argument check and it'll start building graphs. And this is what the diff looks like. So now it's been pretty printed. It's a little easier to read. Of course, I didn't show you the non-pretty printed version, but that would be pretty hard to read. And you'll notice that all the diffs have been pretty printed. And now we can refer to, as you can see, it says diffs written to file test file. So why don't we actually look into test file? And here you can see that you have a tenant admin object as like the first key. This is basically a giant JSON. And you have your root object and the diffs that it has from Postgres to SE datastore and SE datastore to all the SEs that are relevant. In the case of tenant admin, the first one being root network service, there are no diffs, but as you get to the virtual service, you find diffs. And you get the same thing for virtual service runtime. But you'll notice that as I scroll down, there aren't any diffs for SEs because they aren't expected to be on SEs. So this was basically the bulk of my script. The only thing we didn't really cover in this demo is objects at different versions and how it handles that. So I'll just give a brief rundown on how that goes. So between Postgres and SE Datastore, there's not really a concept of walking back in the same way there is between SE Datastore and service engines. So if there's a diff on an object between versions, you'll just see, like, for example, if cloud has been diffed between versions, we'll just bold cloud on both or one, depending on where it shows up. And that'll be our way of reporting to the user that this object has been diffed between versions. And if you try to get a diff on it, you'll get an output message saying you can't diff this object because it's changed between versions. However, if you decide to do that for the SE Datastore and service engines, we'll actually calculate the number of walkbacks required to compare these objects. And if that number of walkbacks is less than the walkbacks that we specified in the call, then it'll actually walk back that object and then give you a comparison. So that was a demo. And again, a few things to note is that calling the script is a little expensive. So as you saw when I was running the script, it took maybe about 6 seconds to run on one root object and maybe 12 seconds, 10 seconds to run on multiple root objects. So it's important to avoid using excessive arguments. So if you don't really care about seeing an object graph for a certain root, because you're really just trying to see a diff that's on one root object, there's no reason to pass in multiple roots because those would not be useful to find the diff. Then argument checker is actually a really important tool that kind of prevents, it kind of saves time because it prevents users from passing in invalid objects and invalid arguments before actually building the graphs and running the bulk of the script. That takes a lot of time. And again, the options that we didn't include in the demo were walkbacks, but I think that's been covered. So moving forward, the main thing that this script needs to address is efficiency, mainly in the amount of time it takes to run. So there are a few things we can do to fix that. And one of them is just multi-threading. So when getting objects out of Postgres, there's a multi-threaded way of getting and saving objects to the data store. I think if we incorporate that into the script, it could help save some time. And another way, which was actually highlighted when doing my code review, was that we could create a subclass when getting Postgres objects. And the reason I'm specifying Postgres is because Postgres really takes the bulk of the time to get objects from. So we could create a subclass structure that actually just gets the object as opposed to getting and saving the objects to the Postgres database, and that would help us save time. So are there any questions on what you've seen so far? All the docs will be written up in Confluence and should be published tonight. So if you guys can't think of any questions, then you guys can always refer to that. But if there aren't any questions, I'll move forward. But yeah, that was my project for the summer. So feel free to reach out. Today is my last day, unfortunately, but feel free to reach out. My email is bandarkar.kunal@gmail.com, and feel free to connect with me on LinkedIn at basically my username is just Kunal Bandarkar.